Okay, so the first thing I want you to do is I want you to open up this document. This document is called Pawn Design Specifications. It is a CAD file. It is located here. So you go to Open. If my Open will open. Come on, let me try again. Open. There we go. Go to Open. Go to your O drive. O drive. Then ON Dubs. Then to AE CAD. Then to CAD 1.2, then to this year, then to a file called Pawn Specifications. After AE CAD, you go to CAD 1.2, then you go to Pawn Specifications. You open that up, and you should have this document. All right, so this one, it does have a lot of specifications on there about your pawn. The reason that we do this is kind of your practice drawing to get ready for your ring design. To do your ring has to be within specs, has to follow all the specifications I give you, or you don't get your ring. You don't get your nice little designed ring. You don't get it casted out of sterling silver in the chemistry classroom. You just don't end up with a ring if you don't follow the specs. So this is a drawing that's trying to get you used to following specs. So we do this kind of as a good lead up to that to get you to learn how to follow some specifications. This one, the specifications are a lot simpler than your specifications on your ring, but there still are several of them. So let's go down and go through these. Your first specification there, just kind of follow along with your drawing with me, is really pretty basic. The overall specs of this ring, or the pawn, sorry, we're doing the pawn here. Pawn, are 1 by 1 inch square by 2 inches tall. Here's one circle with a slash through it. This one is not okay, because if you see, this one's 2.28 inches tall and a 1.4 inch diameter. This is a circular one. That is not okay. To make it okay, I shrink that down to 1 inch tall, or 1 inch diameter and 2 inches tall. And that works and is within specs. All right, next spec. If two portions of the pawn are connected, it may not be thinner than 0.2 inches. So notice this little ball up on top of the pawn. On both of these pawns. This one is connected with a 0.1 inch neck. It's not okay. That's too thin. It's going to be too fragile. It's going to break very easily. This one is a 0.2 diameter. It will be relatively strong. Now again, you're not going to be able to take it and strength test it and see if you can break it in two like my 4-year-old would do. It is going to break. But it will withstand being dropped off the table, being messed with a little bit, and not be extremely fragile. All right. Moving on. Any questions on the first two? Those were pretty basics. All right. Next. Slots or notches. So grooves, slots, notches, things are cut into the ring. Must be at least 0.05 wide, first figure, figure 3, and 0.05 deep, the next figure, figure 4. So let's look at those. So here's the little grooves cut in this top portion of it. This one is 0.03 wide. That is not okay. It just said it had to be at least 0.05. Down here on this portion of it, it's a little cross cut into it. So here on the front face, and here you see the side view on the side face. It's 0.03 by 0.03. Will not work. To make that okay, you have to make it 0.05. Notice it really doesn't change the design of this much, but it makes it so it's going to print out and look good once it's printed on as 3D. Again, you're going to get this as a 3D printed object we're going to print in our 3D printer. So that is okay. Now the next one below, figure 4, talks about the depth, how deep it's cut into the object. Again, this one up here, that little groove is cut in there 0.037 deep. That's not deep enough. It has to be at least 0.05. This one, again, on the side is cut in 0.03 deep. Again, not deep enough. This one on this side is cut in 0.05 deep, and the little grooves up at the top, 0.05. It's almost like the person that did this designed this to be exactly within specs. I don't know who that guy was, but he was pretty darn smart because he designed it like that. Yeah, it was probably Mr. Edmondson, probably. All right, so there's that. Next. Here we have a lot of little tidbits on this one. This one has a lot of specs to it, so we'll take a little bit to go through this. All right, first part of it, number 4. Raised portions must be 0.05 or greater. So the last thing was things were cut into it. This are things that are raised from the surface. This one, notice this little nub here on the top, it's 0.03 wide. That's not okay. This cross, instead of being sunken into it, is sticking out from the surface. It's 0.03 wide. Not okay. Has to be increased to 0.05 wide, totally fine, and totally fine here. But now next, we get to the next portion of this of letter A. When the portion is 0.05 wide, so it is this width, the amount that it can extrude out from the surface of the object, there's some specifications there. It has to be between 0.05 and 0.075. See our next figure down for that. All right. So here's my same little thing, 0.05 wide. This one sticks out 0.101. Sticks out too much, it's going to be fragile. That little nub, the little tab there on the top, is going to break off. Same here. This one sticks out 0.04. That doesn't stick out enough. It won't be real visible. I want it sticking out at least 0.05. So again, this one's under, and this one's over the spec. On this one's exactly on the minimum spec of 0.05, and this one's 0.06, which is in between 0.05 and 0.07. So these both are okay. All right, so that's that portion that's sticking that is 0.05 wide. Next, coming back to the top, letter B. When that raised portion is 0.1 wide, it may extrude from the surface between 0.05 and 0.2. Okay, so scrolling on down here to my next drawing. This one is 0.1 wide, but this one sticks out 0.25. This one's wider than 0.1. It sticks out 0.03. All right, both of these, this one's over my max spec. This one's under my max spec. This one is exactly on. It sticks out exactly 0.2, which being 0.1 diameter, that's okay. It's going to be a little fragile, but it still won't break off real easily. And this one sticks out 0.05, which is exactly the minimum spec. All right, going back up. One more for this list. When the raised portion is 0.2 or greater, it may extrude from the surface the entire size of the object. See the next figure. So here we have some different drawings. We have the girl drawn here. I don't know why I drew a girl, but I did. So here's this one, is this figure. The arm sticking out here is a 0.1 diameter, and it sticks out 0.35. That is not okay because it sticks out more. If it's 0.1 diameter, the max it can stick out would be 0.2. For the legs are the same 0.1 diameter, small, and it sticks out 1/2 of an inch. Not okay, it sticks out too much. It'd have to stick down there 0.2. So two different solutions for this. One is you can make the arms and the legs really stubby, or increase the diameter of the arms and the legs. Actually, honestly, I think this one almost looks a little bit better with a little bit thicker arms on it. So this one sticks out 0.2 in diameter, sticks out 0.35, it's all good. Here, the legs, 0.2 diameter, sticks down 0.5 is good. I did do another example here. This is just kind of a drawing of a cactus. I don't know, it's what I could think of. This entire thing is all 0.2 wide. So you notice this goes from the very bottom of the object to the very top of the object to 0.2 wide, and it's just fine. 0.2 is about the diameter of a pencil. So that really gives it enough strength. Again, if you take this and throw it against the concrete wall, it's going to break. But if you take it and you drop it off your tabletop or drop it on the table, it's not going to be that fragile it will break. If you give it to my 4-year-old, he'll definitely break it. But it won't be real fragile, and it'll hold up and be okay. All right, any questions on all those whole big list of specs? All right, let's look at our next one down. Next one down. No portion of the pond may be less than 0.1 thick, with the exception of small raised surfaces. So the small raised surfaces we already talked about earlier, but this would be one like this. So for example, let's say this is a hand, let's say. This hand has really skinny fingers, 0.03 wide. That's not okay. They're going to be so fragile it's going to break off. This ring going around it on this one, again, at 0.04 wide, it's going to be so fragile, it's going to be very few layers on our 3D printer. It's going to be very fragile, it's going to break. The base at 0.05 is going to be too fragile. This one, I actually think this looks like a better design. Everything's 0.1 thick, sticking out there, 0.1 thick base. That's all good. It's going to have plenty of strength to it, and you're going to have good results when we 3D print that. All right, moving on down. Other little things here. Pieces should have a substantial base on them to keep them upright. See figure 10. So come down here to figure 10. Figure 10 doesn't look like much until you twist it up in 3D. And there we go. We have one very similar to this. I'll be passing around the classroom here in a little bit. This sword. If this is a pawn, it will not stand on the point of the sword very well. You can flip it over, but it still won't stand on the back end of the sword very well either, being that 0.15 diameter. So you'd want to stick it into a base, something like this, and that is okay, and it will stand up. and that'll be great. So that kind of follows that spec. Next. Portions of the pond may be as thin as 0.1 if they're supported on both ends. So, on this one, and I have an example of one similar to this, I'll pass around a little bit. This little rod is a 0.1 diameter. It exceeds the length of 0.2, but it is supported on both ends by this top and bottom plate, so it is okay. Again, it will be somewhat fragile, but you will be able to drop it, and it will survive pretty easily with this. So that's kind of what that one is. All right. Next. Pieces may have multiple supports. This one's kind of confusing. Multiple supports less than 0.2 inches if the cross-sectional area is greater than 0.06 or is 0.06 or greater. So what that, what that's showing you is, so here's a top view of this. These circles here, if I double click on these, it tells me the area of this circle is 0.0238. This one is 0.0201. This one is 0.0186. You add all those numbers together, you get 0.0634, which is greater than 0.06. What that's telling you is if you had this as a 3D object, here's some cool lofted little things coming up here to this top piece. These are thinner than the 0.2 minimum. But since there's multiples of them that add up to more than 0.06, this will have enough strength. I'll pass around one around here in a moment that is very similar to this theory that has a bunch of 0.1 diameter objects. Listen. 0.1 diameter objects that are multiples of them that add up to greater than 0.06. And it really is okay. It's one that was printed several years ago, and it's still in one piece. It hasn't been broken yet. So it's really doing pretty good. All right. Any questions on those things there? All right. Let's look back up to our list here real quick. All right. So with this, that's kind of all your specs you have. A lot of different little things to follow by. You can ask for clarification, obviously, as you're finding things you're thinking about doing. Here is the next little part. So with this, you're not just going to draw a pond. That's going to be what we start with. You're going to start with your pond. You're going to get all checked off, all okayed with that. You will create as a STL file, which we can 3D print. Then from there, you're going to do the rest of the chess set. The king, the queen, the knight, the bishop, and the rook, the other 5 pieces of the chess set. For those, your overall specs can increase to 1 1/4 by 1 1/4 square by 2.75 tall. So you get a little bit more size for those other parts. All the other detail specifications have to stay the same, so all those details have to be in there and be the same. So it gives you a little bit more freedom on size for your other parts. Last but not least for this project, you will create a chess board. And I did notice this was spelled wrong last hour. I thought I fixed it, but I must not have. Board. You will make a chessboard that is a 2x2 chessboard with 1/2 inch thick squares and make those alternating colors. So with that, I have some examples. So let's see. Oh, no, that's specification sheet. So here's some examples. Here's a person that did these little tiki looking guys. This one was his pawn, his or hers. I can't remember. I'm pretty sure this was a guy. I can't remember who it was though. And it was just fine. It really worked pretty well. This is one of his other pieces with the little spear on it. The spear was a 0.15 diameter here, I think, and tapered down to about 0.1 here at the hand. And it was okay. It actually did go out past the specs here a little bit. This is where I increased more specs because it was somewhat fragile. I think this may have ended up breaking off. So that's a little bit out of specs for our current specs. These pieces were just fine. This is a 0.1 diameter rod here. Just fine there. This piece, however, was not okay. He lost a few points on this when I graded. Because if you look at this, these little things here are teeny tiny. That's way under the 0.05 spec. And then the other part of it, close your eyes when we flip this underneath and look under the skirt. But underneath here, these portions weren't extruded very much. This would have been okay. Focus and listen. Would have been okay if they would have extruded this back into this object here. Just made these full objects came all the way back. And then got rid of these tiny little rectangular pieces here. If they would have just done these leaves, extruded them back to the object, it would have been fine and it would have turned out really nice when we printed it. Now here comes the other little tidbit. We don't print all of these things, all your other chess pieces, but per class, there's typically, I let everybody kind of, anybody that wants to print theirs can submit it. The teachers kind of vote on it and we pick the best ones out of the class to print. So it may be 1 or 2 per class that we print. if they are of quality of deserving to be printed.